Hey, I'm Doug Robertson from Shelly, USA, and I'm here to talk to you about one of the common questions I hear all the time about the naming conventions for Shelly products. People ask, what does PM mean? What do the numbers mean? What does this mean? And it's a really simple breakdown. If you see a number beside the name of a Shelly, that's either the number of relay channels or the number of inputs. If you see PM, that stands for power measurement, which is plus or minus 5% accuracy, and it's an active measurement of the circuit you're controlling. The EM designation is for energy meters. This is a passive measurement, and it's either plus or minus 2% or plus or minus 1%, depending on factory calibration. The blue designation is for our Bluetooth products, which are now being reworked to include Zigbee. If you see Plus or Pro in a product name, that represents our second generation of Shelly devices, whereas Gen 3 and Gen 4 are later improvements to those lines. Finally, we have a line of Z-Wave products that are, their designation is Wave. And so if you know these individual points, you can quickly determine what a specific product is. To give you an example, Shelly Pro 4PM is a second generation device with 4 relay channels that includes power measurement. So the difference between power measurement and no power measurement is a device that just has a number, has what we call dry contacts. That means that the power supply for the microcontroller is isolated from the power supply for the actual relay in the device that's handling the switching. A device with power measurement, by contrast, is internally connected. Everything is sort of in the same pot, so to speak. If you have a device like Shelly 1PM, that will have electrical safety features like over wattage, over current, over voltage, and those are software settings that you can define based on the electrical system in your home. To give you an example, here in North America with 120 volt AC at 60 hertz, we have what's called split single phase. You'll have phase A and phase B. Those are 180 degrees out of sync to each other in reference to neutral. So you can't really just combine two of those lines. You'll get a pop as your breaker trips. But you'll also notice that there's a slight difference in voltage on the two sides of your home's electrical service. This represents the distance between the breaker going back to the transformer, and it's normally slight. For example, 119.2 volts versus 121.0. That's the normal sort of difference you'll see, though you can see slightly less or slightly more. I grabbed a video from one of my colleagues, Urban, who's in our office in Slovenia. He does these great animations for showing how to set up a Shelly device. It's going to start showing you to turn off the main breaker. Obviously, you'll probably just want to turn off the breaker for the individual circuit. Here you can see, you turn off the breaker, you remove the wall plate, take out the screws and pull the switch out. You'll disconnect the wires from the switch, and then you bring in Shelly 1PM. So first you're connecting the O terminal to the load, to the fixture. You're adding a neutral wire to the bundle. That's not absolutely necessary, but we'll get to that. Connect the line terminal. Then you're connecting the SW terminal to the top pole of the switch and adding a connection to another line terminal. Again, they're internally bonded. So this is providing a loop to the switch. Shelly treats this as a variable. Is voltage present, yes or no? You button it back up, put the plate on, flip the breaker back on, and you're ready to go. Now, what I'll show you next are some wiring tips for use with Shelly 1PM. So if we can switch over to the workbench view. Now here you've got a couple of pre-wired ones that I did earlier. This is an outlet. You can see I've got neutral connected to one of the screw terminals and then coming into Shelly 1PM. If I want to pass to a downstream wall box, I can use the other terminal on the outlet. If I don't need to, I just connect neutral here, which I'll do that regardless to power the return path for the circuit. Then I'll add line coming in. Here you've got the O terminal going to the other side of the outlet. So this is a very simple setup, and you can see it doesn't take a lot of space in the wall box when you set this up. When you're wiring, you want to take about an inch off of one end of the wire. So that's not quite an inch, but I can still illustrate. Grab your pliers, bend this into a hook. The reason you want the hook is so that when you put it onto the switch terminal here, I can bend it with the pliers to make a nice tight fit. And then I can lock it down with the screwdriver. You'll notice I'm turning clockwise, so that's why I have the hook pointed in that direction. So we've got that locked down nice and tight. We're going to repeat this with the other wire. Again, we're going to take off just under an inch. We'll grab the very tip of the wire with the pliers, bend it into a hook, and we'll loop that onto the terminal. I'm just using these two fingers to keep the wire pulled tight. And you just need a little pinch on this. Sorry for being a little clumsy today. Okay, so that's all the squeeze you need. And when you're locking it down, it'll pull it up underneath. Okay. You bend the wire out like this. Now we're going to trim off what we don't need here. Just going to cut it right there. On this side, you're going to take about 3/16 of an inch, plus or minus. The idea behind doing 3/16 of an inch is you want to have a good connection in the terminal, but you don't want so much exposed copper that you're going to see it when it's sticking out. So the top pole goes into the SW terminal, the bottom is going into a line terminal. All right, so I'm still being clumsy today. So let's get this hooked in. All right, you can see there's no exposed copper there. I'm just going to lock these down real quick. Now normally I use pliers to make this bend so it doesn't pull out, but since I'd already made the bend before locking everything down, I was fine. You can see this is going to fit very nicely inside the box. I can adjust it a little bit more to make it a tighter fit. And that's going to sit very nicely inside the wall box. I'd like to take this opportunity to thank you for joining the very first episode of Wired for Shelly, and hope you see me again next week. Thank you.